Hello and welcome to a new session in the series Architecture Design Patterns. In today's session, we discuss the pattern Outbox Table. Let's get started. So, to recap our use case of a flight system, we had this monolith application on a mainframe on data center, and we had refactored it to using the strangler pattern so that we had component on the cloud and a component on premise. And then we introduced the command query responsibility segregation, and this is relevant for today's discussion since one of the things that we have introduced in the asynchronous pattern, is that once the passenger has booked a flight, the flight will be booked and written in the database, and then a booking event will be published to a Kafka topic. This will be then consumed by different services. Let's see what problems arise with this situation and how we can solve them using the Outbox table pattern. So here is one view that is focused on this use case. The passenger uses the mobile application. Remember, we are using Archimate annotation served by. And this mobile application is served by the booking APIs, which is assigned to the booking service. This will write the data to the Mongo database, again served by the Mongo database, and publishes, triggers an event, booking event, which will be published to a booking Kafka topic or any other message bus such as Azure Service Bus, Azure IoT, Azure Event Hub, and so on and so forth. So what are the problems that we have with this situation? First problem, we have strong coupling between writing the booking into the MongoDB and publishing the booking event. This is problematic in two ways. One way, because of latency. The mobile application is being blocked until the event is being published and the record is being written in the MongoDB. Whether they are being done in parallel or one after the other in serial, this still way of strong coupling situation. The second problem arises from the strong coupling is that when we have the writing to the booking event in the Kafka topic fails, we do retries, and retries cause more latency. Even when the writing fails altogether, we have to write the event into a Kafka dead letter queue, or if the Kafka cluster is entirely crashed, in that situation we have to do a rollback from the MongoDB. According to the textbook on the design pattern itself, you find also the transaction nature. There is no way that you can enforce a transaction on both of the MongoDB and the Kafka message broker at once. Since these two of them, one of them supports transactions, the database, but there is no sense of transactions in Kafka at all. Hence, this is also talked transactional outbox table pattern. I hope now that you are convinced that we have a problem in this situation. Let's see how the outbox table pattern or transactional outbox table pattern solves the situation. Here I've brought you the target architecture. In this case, the passenger makes the booking over the mobile application, which communicates with the booking APIs, and the booking service now writes the record in the database and returns a successful response to the mobile application. In this sense, the mobile application is done with the booking. We know now that it's written into the MongoDB. When the booking is being written into the MongoDB, we write two records. A transaction that involves two records. The first record is the booking itself. The second record is the booking event in an outbox table. This is similar to an outbox tray when you have a secretary preparing all of the mails in the traditional sense for her manager. There will be an outbox tray, and this letters in the outbox will be sent on the next day to the post office. So this is the same analogy. In the Outbox table, we'll have the booking event. Optionally, we could have a trigger to the background daemon that's running in the background, asynchronous, independent from the foreground service that's responding with the mobile application. And this will access, this is an access annotation in Archimate, will access the Outbox table. And because of the trigger, this will be as near as it gets to real time and asynchronous. It will fetch the record from the Outbox table and publish the booking event to the Kafka topic. It will have a mechanism for supporting retries, error handling, dead letter queues, and any other exception handling that you can think of. This way, we have decoupled the writing to the Kafka topic from the writing to the MongoDB. And this is, in essence, the theory behind the Outbox or transactional Outbox pattern. I hope that you find this video and this session insightful. I hope that you can use it also in your day-to-day architecture work as an enterprise architect. See you in future sessions.